Hello everyone, and welcome to Geotech. So we're going to continue from the types and component of computer system. Okay, and we're going to continue from analog and digital data. We talked about in chapter one, talked about episode one, if you want to call it that way, because we're in chapter one. We talked about the hardware and the software. And now we want to talk about analog and digital. So when we talk about that computers can only understand data which is in binary form, we're simply talking about digital data. Okay, that is what a computer can understand. You can understand data in binary form, which is like base two, like zeros and one. Those are the values. But in the case of analog, they are like real world data, right? In the sense that they measure physical quantities. Okay, the major physical quantities, that is analog, right? So there are physical data that can change, okay, from one value to the next. It is not in discrete, it's not in zeros or one, it is just measured in physical quantities. Okay, all right. Now, they said if the analog data is being sent to the computer, it is first converted into the digital data. And I'm going somewhere with this, trust me. This is going to make a whole lot of sense when we get to what we call sensors. That is in our input and output devices in chapter 2. It's going to make a whole lot of sense. So hold on to this. Hold on to this in your heart, right? Because it's going to make a lot of sense, right? So if analog data is being sent to a computer, it must first be converted into digital data. Now, this is done by a hardware known as the analog to digital converter, what we call the ADC, right? So, if the computer is controlling a device, such as, let's say, for example, a motor, right? Then the digital output from the computer needs to be converted into the analog form, and this is now done by a digital to analog converter. So whenever you want to send in physical quantities, that's it, right? Whenever you want to send in physical quantities, right? You send in using the analog digital converter, right? But if the computer is controlling a device, such as a motor or an actuator, right? Then the digital output from a computer is then converted into the analog form that will make that mechanical device to move, right? Either in the form of a rotary or in a linear movement. Okay, so if you talk about in the form of the rotary, it revolves round and round and round and round. But in the case of the linear, it just goes straight, kind of like a door, right? Your supermarket doors, right? So it opens, it closes. Whenever it senses the presence of a human, or it senses a presence, it opens, and when there's no presence, it closes, right? So it uses what we call the motion sensor, right? And yeah, that's essential, right? You know, it came early. It came early, so we can be glad that it did, right? So that when it actually comes, we can just have understanding too. So hold on to this. It's a very very important piece. And the next one is the main component of computer system. So let's look at the main component of the computer system. Now, a typical computer system is made up of what? Your hardwares and your softwares. Okay. Now, let's look at those input devices, and let's look at examples of them. Yeah, we're talking about the main component of the computer system. Right. So it's made up of both the hardwares and the software. Now we have, let's say, input. Okay. So for input, for example, we have input devices, which is used to send data to the computer system. If you're wondering what it is, we have our keyboard, our mouse, cameras, microphone, sensors. You see what I did there? Sensor, scanner, because sensors, they help to be able to send this data, and this is done usually with the help of the analog to digital converter, right? Then we have the scanner. Then we have the output devices, right? The output devices, for example, we have the monitor, we have the printer, we have the speaker, we have the projector, we have the plotter. Okay, what you can see like your graph, and then we have like plotter. So you see as a graph, you see as a plotter. Then we have the secondary, like auxiliaries. Okay, your secondary storage devices like your hard disk drive, your solid state drive, your pen drive. So yeah, those are just those major components. Now, they said the internal hardware that we've seen. Now, let's look at their device. They consist of four key components. Okay, so let's look at them. We have the CPU, which is contained in the motherboard. We have the internal hard disk drive or solid state drive, because notice that every system coming with this, it comes with what we call the solid state drive. Now, you're wondering, what is this man talking? How do we even know a system that has a solid state drive? Yes, we know it's on our laptop, but how do we even know? How are we even sure that my laptop is having a solid state drive? I got you covered. Trust me, I got you covered. We're going to we're going to explore this right about now. So what you're going to do is this: click on the control panel. Okay, then categories. Don't forget. Then again, systems down here. Defragment and optimizer drive. And if you click here, you're going to see that, notice my media type. I have a hard disk drive and I have a solid state drive. This is one of the ways you can know what kind of internal storage device you have. If it's a solid state drive or if it's a hard disk drive. I hope that makes sense, right? Okay, so let's go. All right, now we have the random access memory, which is your RAM, and then you have your ROM. Okay, now remember, these are internal hardware devices. Like you can't actually see them unless you actually dismantle them, like literally your motherboard. Okay, so they're all embedded here, and this is the ones you can see, like your monitor, your printer, your keyboard, and of course your mouse. Hope you're having fun with this. Now, your CPU. We've talked about your CPU, right? It is a part of the computer that can interpret and execute the commands from the computer hardware, the software. So it's that part. They help to interpret, they help to execute. Remember, it's not the only one doing. There are so many components that are part of the CPU, right? So it is normally part of the computer motherboard. Now it is made up of these components I'm about to talk about. Okay, and we see the CPU is often referred to as your microprocessor, which is like a single integrated circuit, and people see it as, it's often, sometimes people see it at the heart of most PCs, or people, yeah. They said sometimes people tell you, or some articles will tell you that it does major work of the computer. And this is true. Okay, it's funny enough because sometimes we could see the motherboard as the CPU, but they're two different things, right? They're two different things. Okay. Okay, so let's look at it. Now, the CPU is made up of the control unit. Now, the control unit controls the input and output devices in the system. We have the arithmetic and logic unit, which is an ALU, right? So which carries out a form of calculations and makes form of logical decisions, comparison, and then we have what we call the registers. Okay? All right. Then internal memory. Now, let's pause a break here and let's look at this categorically. Now, for internal memory, we have the random access memory, we have the read-only memory. Okay, that's what we have. Now, the random access memory, right, which is the internal chip, where data is stored temporarily when running applications. Okay, now these memories can be written to, they can be read from. Okay, now another thing we need to know about the RAM is the contents are lost when there is a power failure, and that's why we refer to them as volatile or temporary memories. In the case of the ROM, it's not so, because the ROM stores information that needs to be permanent. It means it often contains, right? So it's permanent in nature. Whatever information is stored is permanent. And this is configurations of data for your computer systems, right? So the chip that is used for like the ROM cannot be altered and can only be read from. Hence the name, read only, right? Can only be read from, so it cannot be written to. So one of the main advantage of the ROM is that the information stored on them is not lost, whether there's a power failure or not, and that's why we see them as a permanent memory or non-volatile. Okay, now let's look at the BIOS, which is the basic input and output, right? And now the ROM contains some coding known as the boot files, where the operating system loads from, and this is referred to as the basic input and output system. So when the computer is turned on, this is what the BIOS does. It carries out what we call hardware checks to find out if all the devices are present and whether they are functionals, and then it loads the operating system into the random access memory. Where you didn't see that coming. I know. Now, the BIOS stores the date, the time, system configurations in a non-volatile chip called what we call the CMOS. And the CMOS is known as the complementary metal oxide semiconductors. And this is usually battery powered. Okay. Now, it's too much. I know this information is looking too much. So let's break it all down. Okay, between the RAM and ROM, I think that will make a whole lot of sense to people like, oh, he's just saying so many things. I know. Trust me, this will be second nature by the time you listen to this over and over and over again. Now, the RAM is a temporary memory device. The ROM is a permanent memory device. Okay, see? Cool, right? The other one is, it is a volatile memory, while the ROM is non-volatile memory. The next one is, it can be written and read from. It's random access. But from ROM, which is read only, from the name, it is only read only. It means data cannot be altered. When something is written, means it can be altered. But when something is read only, it means it cannot be altered. And of course, it is used to store data, file, programs, operating system currently in use. It can be increased in size. Yeah, sure. You can actually increase it, right? What do I mean? This Control Alternate Delete, Task Manager. And then we can have this. Now you can see your memory right here, right? You can see your CPU, which is your central processing unit, and then you can see your things, right? Internal memory, and then you can see that this is a lot of memory that is actually being carried out right now. Okay, and you can see that the ones that are like your Windows Explorer is actually using like 71 MB, Task Manager like 80, Microsoft Edge. Is my Microsoft Edge? Yep, it is. It is. I'm using it. Okay, and a whole lot of them is ongoing. Omen Gaming Hall. I don't know what that is. It's not open here, but I'm trusting. Probably let me see. Oh, it's a command center, so it's not like it's like game. I was wondering because I don't have that on my laptop. So we have them here, right? And so many of them. Okay, and you can actually check to know the numbers of RAM you have. You can just type in system information and then click on open, and then you can see your system information. And if right here you can see how many RAMs you have. If you come down right here, you should be able to see it. You can see your boot device where it's booting from. You can see your total physical memories. You can see your installed physical memory, which is your RAM, 8 gig, and you can see the physical memory. You can see the total virtual memory, which is 22. My virtual available virtual for me, page, file space, a lot in system information. It gives you an idea to be able to know how your system is operating. Okay, and if you're wondering what's the username, you can see right here, your username, right? Okay, for those who are using commands, CMD, to do some things like change files, open some files, you need that, right? To know where it is. Okay. Okay, now for the ROM, it is used to store the BIOS and other data needed as startup. Remember, it stores in your date, your time, system configurations, and yes, and in what we call non-volatile chip, right? Called your CMOS. Input and output device. Trust me, it's just a summary. We're going to explore this in depth when we're talking about chapter 2. Okay, just stick with me on this. Okay. Now, your input devices are hardware that allow data to be entered into the computer. Right? We'll cover that in chapter 2, like I said, right? And we have a lot of them. We have input data, we have direct data entry. We'll talk about that. Okay? Then let's talk about the output as well. If the input are hardware that allows them to be entered into the computer, then what about the output? The output helps to be able to display information to the computer, right? From the computer. Now, okay, you can see that an output device shows the computer output in a form that is understood by a human. So it simply means that if you can be able to make sense of what is on the screen, then probably that data is outputted. Okay, so input devices. Input devices. As we said, a conclusion of everything we've talked about is any hardware device, right, that allows a user to enter data or instructions into a computer directly. So there are any hardware device, it allows you to be able to enter data or instructions. Then output, on the other hand, is any hardware device that takes the output data from a computer and puts it into a human readable format or uses it to control another device. Yeah. Now, use to control the device. You're wondering how? Okay, I get you. I know you have those questions. I'm going to answer right here in this video. Now, use to control another device. Talks about when you have like two monitors, right? And you want to either extend your screen or whatever. At that point, you can actually use there's a main monitor that can control other monitors as well. Okay. Yeah. An input device can send data to another device, but it cannot receive data from another device. Its input it can send. In the case of the output, it is capable of receiving data from another device in order to generate an output, but it cannot send. So input can send, but cannot receive. The output can receive, but cannot send. Hope that makes sense. An input device are necessary for a computer to receive command from its user, okay, and data to process. So when it receives it, it's able to process that command, that instruction. The device is under the control of the user or can be in the form of data direct entry, right? That has no form of human interaction, a little of it. IP devices on their hands are needed by a computer so that it can share the result of its processing with a human. Input device, on the other hand, right, can be fairly complicated because they have to ensure that the user can interact with the computer correctly. But output devices are less complex than input because they only have to just turn computer signals into the output. Is it too much? I hope not. Backing storage. Now, backing storage are used to store large amount of data, right? And that's what the backing storage is, right? So it can take the form of internal, right, and known as either your HDD or your SSD. Now, the computer main internal storage where the application softwares, your operating system, files, etc., are stored, right? Now, a key feature of the backing store is that it must store data permanently. That is, it must be non-volatile. That's the backing store. It's different from your internal memory. You need to know that. So we'll talk about the backing store. They are used to store large amount of data, such as your files, your application, right? Even your operating system, etc. Unlike your RAM and ROM, backing storage is not directly addressable. That is, it cannot be read by the CPU. Anything that can be read by the CPU is your internal memory. And I'll show you right here. See this? Right here. Right? So this is actually being read by the CPU. But anything like your RAM and ROM that is not directly addressable, right? It cannot be read directly by the CPU. So that's one way to look at it. So one way to see the difference between, okay? Now, the data access time for RAM and ROM is much shorter than it is for backing store, right? So backing storage is considerably larger than RAM because it is less expensive per byte. So let's look at the difference between internal memory and backing storage. Now, for RAM contents are lost, right, where computer is powered down. Okay, and another one is the ROM contents are readable only. Yeah, they're readable only. But in the case of backing storage, they hold their content permanently, even when there's a power down. The RAM and ROM are smaller memories, are much smaller memory than backing storage. The backing storage have considerably large capacity to store data than the RAM. Data access time on RAM and ROM is extremely fast because it is directly interacting with the CPU, right? It's so fast. But the The backend storage has to slow a much slower access time because it is a backend storage. It has large files. So obviously, if it's large, it means it's going to take a lot of time. But we're not talking about the time here because the time, the access time is. Are you looking at it from the point of the HDD or the SSD? So you're just putting it in categories, okay? Because it's fast. Access time is fast, much extremely fast, but not fast as the RAM and ROM. No, fast as RAM. It is much expensive per byte than backend storage device. It's cheaper, right, than the RAM and ROM. Okay. The RAM and ROM are fixed inside the computer, their internal memories. But the backend storage can either be fixed or can be removable. Yeah, I have a backend storage right here, and I'll show you right here in a minute. And right here, this PC, you can see that I'm having two right here. This is the SSD, this is the HTC, right? But it's a backend storage. It means I can eject, right? Okay. Now, the RAM and ROM can be read directly by the CPU. We've talked about this. And of course, before data can be on the backend storage device, it can be read by the CPU, but it must first be moved into the RAM. This means backend storage is not directly addressable by the CPU. We've talked about this. So before any data on the backend storage can be read, it is now moved into the RAM. Okay, so we're going to stop here, and in our next video, we're going to be looking at the operating system. Do have a nice time. Bye bye.